They're the most terrifying waves on Earth, not because they cross oceans, but because they don't have to. Mega tsunamis don't announce themselves with distant earthquakes or hours of warning. They happen instantly. 1 second the world is stable, the next an entire mountainside collapses into water and turns a quiet fjord into a vertical wall of moving ocean. No sirens, no time to run, just gravity, rock and water moving faster than the human brain can process. And in Greenland, this has happened twice in just a few years. Greenland isn't usually where people picture tsunamis. It doesn't sit on major subduction zones like Japan or Indonesia. There are no great offshore faults snapping and rebounding. But what Greenland does have is steep, over-steepened mountains carved by glaciers, narrow fjords that act like natural wave amplifiers, and ice that has been quietly holding entire slopes in place for thousands of years. When that ice weakens or disappears, the landscape doesn't gently adjust. It fails catastrophically. The first of these modern mega tsunamis struck western Greenland in June of 2017, in a remote region called Karrat Fjord. This is a place of sheer rock walls plunging straight into the sea, carved by glaciers that once filled the fjord from floor to ceiling. Above the fjord, an unstable mountainside had been creeping for years, fractured and weakened by freeze-thaw cycles and a long-term retreat of ice that once braced it. On June 17, without any earthquake trigger, around 35 to 58 million cubic meters of rock suddenly detached and collapsed straight into the water. When that much mass hits a confined body of water, it doesn't create a normal wave. It displaces the fjord itself. The initial impact generated a tsunami with local run-up heights exceeding 90 meters near the landslide site. That's a wave taller than a 30-story building, rising almost vertically up the opposite cliff face. The fjord acted like a cannon barrel, forcing the water forward rather than letting it spread sideways, and a wave raced outward at extraordinary speed. About 32 kilometers downfjord sat a small settlement, a village that has since been abandoned following this event due to the risk of future mega tsunami events. By the time the wave reached the village, it had dropped to around 1 to 1.5 meters in height. But that statistic hides how destructive it still was. The wave surged inland, lifted buildings off their foundations, and swept debris through the settlement. 11 houses were destroyed or badly damaged. Infrastructure was ripped apart. 4 people lost their lives, either drowned or carried into the freezing water. In a community of only a few dozen residents, the impact was devastating. What made the Karrat Fjord tsunami particularly unsettling was how it was first detected. Seismometers around the world initially recorded it as a small earthquake. Only later did scientists realize that the seismic signal came not from fault movement, but from the violent impact of rock hitting water. The Earth itself had rung briefly from the force of a mountainside collapsing into a fjord. It was one of the clearest warnings yet that tsunamis don't need tectonics. Gravity alone is enough. 6 years later, Greenland produced something even more extraordinary. On September 16 of 2023, a massive rock and ice landslide occurred in Dickson Fjord, an isolated and rarely visited fjord in eastern Greenland. Here, a steep slope that had once been stabilized by glacial ice finally failed. Roughly 25 million cubic meters of material plunged into the fjord in a single collapse. The geometry of the fjord was even more extreme than at Karrat, narrow, enclosed, and flanked by sheer rock walls rising hundreds of meters above the water. The impact generated a tsunami estimated at around 200 meters high, or roughly 650 feet. That places it among the largest tsunamis ever recorded. This was not a wave you could surf or outrun. It was a moving wall of displaced water that slammed into the fjord walls and rebounded back across the channel. Instead of dissipating, the energy became trapped. What happened next is what stunned scientists. Rather than fading away, the water in Dickson Fjord began to slosh back and forth in a standing wave known as a seiche. Every 92 seconds, the entire fjord rocked from side to side like water in a bathtub. This motion continued not for minutes or hours, but for 9 straight days. Each oscillation pushed against the fjord walls and the surrounding bedrock, injecting rhythmic energy into the Earth's crust. Seismometers across the globe began recording a strange, perfectly regular signal. It didn't look like an earthquake. It wasn't sharp or chaotic. It was a slow, steady pulse, repeating again and again. Eventually, scientists traced it back to Greenland. The fjord itself had become a natural resonator, turning ocean motion into seismic waves that travelled through the planet. Amazingly, this signal was detected as far away as Australia. A fjord in eastern Greenland was literally shaking the Earth on the opposite side of the world. Satellites like SWOT and Sentinel-2 later confirmed the water surface tilting back and forth in sync with the seismic data, visually capturing the standing wave that no human had witnessed directly. Unlike the 2017 event, the Dickson Fjord tsunami caused no known fatalities, largely because of its extreme remoteness. There were no towns in its immediate path, but the absence of casualties shouldn't be mistaken for a lack of danger. Had a settlement existed within the fjord, it would have been obliterated. Even research vessels in nearby waters could have been capsized without warning. Together, these two events reveal a pattern that is deeply unsettling. Both tsunamis were triggered by landslides, not earthquakes. Both occurred in narrow Greenland fjords where water has nowhere to escape, and both were linked, directly or indirectly, to the slow destabilization of slopes once supported by ice. For thousands of years, Greenland's glaciers acted like structural supports, pressing against valley walls and holding fractured rock in place. As the climate warms, those glaciers thin, retreat, or vanish entirely. When that happens, the stress balance in the surrounding rock changes. Cracks widen, slopes creep, entire mountainsides that were once stable suddenly become primed for collapse. Add to this the effects of permafrost thaw, where frozen ground that once acted like cement begins to soften, and you have a landscape increasingly prone to failure. Water infiltrates fractures, freeze-thaw cycles intensify, and gravity does the rest. None of this requires an earthquake, and none of it provides warning. The danger is not limited to Greenland. Similar conditions exist in Alaska, Norway, British Columbia, and Patagonia. Anywhere steep slopes meet confined water and retreating ice, the potential for landslide-generated megatsunamis exists. In fact, one of the largest known megatsunamis in history occurred in Lituya Bay in Alaska in 1958. Where a landslide produced a wave that ran 524 meters up a mountainside. Greenland is now joining that category, not as an anomaly, but as a preview. What makes this especially concerning is that these events don't need to be larger to become more dangerous, they just need to happen closer to people. Greenland's population is small and scattered, but Arctic shipping is increasing, tourism is expanding, and scientific operations are becoming more common. A fjord that is empty today may host ships tomorrow. As the Earth continues to warm, ice will continue to retreat. Slopes that have been locked in place since the last ice age will keep failing. And when they fail into water, the physics are unforgiving. The wave is born the instant a rock hits the fjord. No warning systems can outrun gravity. No evacuation plan can beat a wall of water rising hundreds of meters high in seconds. These Greenland megatsunamis aren't freak accidents, they're signals. They're the sound of the planet adjusting to a rapidly changing climate, one mountainside at a time. And the more the ice lets go, the more often the ocean will answer back. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.